Hello everyone. This is the demo video of the data mining component by Group 15. The team members are Iti Bansal, Neel Kirit, Mansi Somnani, Nabiha Raza, and Priyanka Punjabi. I, Mansi, would like to focus today on the goals of this data mining component. The main objective of data mining in big data is to process, structure, and derive values from massive blocks of data. For our data mining component, we have selected the IMDb database. It is a free user-maintained dataset for over 4 lakh movies, television series, and video games. It contains information such as title of the movies, the genre, cast, and user ratings. We have used the classification data mining technique today and have performed the analysis over here based on naive Bayes and decision tree classifiers to predict the success of movies on the basis of average user ratings. The steps in data mining for this dataset are as follows: preprocessing, feature extraction, feature selection, classification, prediction, and accuracy comparison, followed by the final result.
Hi, I'm Iti and I'll be discussing about the data visualization part using ggplot in R. Before we go on doing the actual data mining, we have to explore the different type of features which we selected during the feature extraction process, and some of them which we want to dig into are the categories, that is the profession, genre, runtime minutes, average rating, and the number of votes. I want to explore what are the different type of professions which are popular among the people in working for the movies. To represent this, I have used a bar chart. In the y-axis, it gives me the count, that is the number of movies for which a profession for a particular person was there, and so we can clearly see that actor and actress are the most popular type of professions, and production designer and composer is not so much popular among people. Next, I want to explore what are the different regions in which the movies were released, and in which regions most number of movies were released. As we can see here that US was the region in which most movies were released. Now I wanted to know that how many movies were released between the years 1890 and 1920. So I have limited the access to 1890 and 1920. We can see that most number of movies were released between 1910 and 1920. Now I'll be moving towards a bit more complex type of chart, which is the stack bar chart. I want to explore the average rating of the movies by the genre. So genre is the attribute which will be used for stacking the bar charts. And I've used the R Color Brewer package to create the color palettes here. From this visualization, we can see that the average rating of most of the movies was between 5 to 7.5, and the family, drama, and comedy were the most popular type of genres. Now I want to explore the correlation between the average rating and the number of votes. The exploration is done with the help of scatter plot, and genre is again used to distinguish between if there is any cluster. but we don't see any such clusters coming out through this graph. Now I'll be taking help of the box plot to understand more about the genre ratings and the genres and the runtime minutes. Here I've plotted the runtime minutes against the type of genres, and I've used the ratings to actually decide the mean and the spread of uh, the box plots. So again, we can see that family and comedy are the types which are spread widely among these all other genres. With this, we come to an end of the data visualization part. Next, we'll be moving towards the data mining part.
Hello, so I'm Nabiha Raza and I'll be walking through the feature selection part. The feature selection is the most important part when it comes to data mining, and it's the first step. Basically, what it is like it's the process where you automatically select those features which contribute most to your prediction variable or output in which you're interested in. And there are a couple of parts in feature selection. The first being data mugging or data wrangling. It's also called data merging. That comes binning, label encoding, and then finally we come up with a correlation matrix, followed by on which we actually select our features that we'll use in our model. The first part is data mugging, and this is basically data merging. We pick up two columns from different tables and then just merge them together for whatever we think are best and will contribute the best in our data modeling. Because that's why we do that is because in some cases we have to deal with messy data or incomplete data, and the raw data is not usable. So data mugging is the process where this data is transformed and mapped from one raw data to another, which makes it more valuable. The next part is binning. Binning is basically the process of splitting univariate data into consecutive bins. And why is it required? Because we need continuous data. This data that we're seeing right now is not continuous. We've in our code we've divided the bins into for runtime minutes, for example, into 0 to 15, 15 from 30 is another bin, and 30 to 60 is another bin. So we've divided the data into multiple bins so that later we get a numerical value for this. And in this whole process, while we were doing this step of feature selection, we were doing data cleaning side by side. So even in this part, data cleaning also took place, and I'll walk you through the code as well, and you can see it from there as well. But the null values were removed with the mean values. Some attributes were removed and stuff like that. So it's basically data cleaning is happening in every part. Then comes label encoding. It's the last part before we actually get the correlation matrix. And what label encoding does is basically it converts all the textual format, the text that we had, for example, for the category in which they were drama, comedy, all the strings, we convert it into numerical values, and for that we use this particular code snippet. And so finally, when we run this code, we see that the entire data frame turns into all the numerical values, and so that we can do our correlation, because it has to be done with variables, and numerical values have to be compared to each other. Next up, we've got correlation matrix. Correlation matrix is the one that we wanted in the first place for the attributes to be selected. And there you go, we've gotten our matrix, and then from here we can see that the blue part is the one that in which the attributes are proportional to each other, and the negative one was where it was inversely proportional to each other. From From here we can see that we have a relation of start here with my average ratings, and I have a genres is related to my average ratings, and so is my runtime minutes related to my average ratings. And these are the attributes that we've chosen for our model to be used in our naive Bayes and decision tree. So now I'll walk you through the code. Let's go there. Let's start with the feature selection part. Like I said, on every stage the data cleaning will happen. So even here the start here that was actually in the string format is being converted into a numeric value. Same is happening for end year, runtime minutes, average rating, and num votes. Now we'll install the library caret to do the encoding and binning at the same time. Here we're making a different new copy of genre ratings as genre ratings encoded. And so let's go when it's built. Let's see our data frame and data mugging has happened, right? So we should see a lot of data merging of columns here, and we can see that some columns are also not available, but the data is being merged successfully. So let's go ahead and check, install our new library, and there again the data cleaning is happening, and we're just the values that we saw were null. We're just kind of deleting those. So end year was empty, job was empty, primary year had null values, birth year, death year, so all of them are removed now. So let's go on the part of encoding and binning at the same time. So now encoding of nconst is happening. The nconst is encoded, genres is encoded. Now we'll do the binning. And binning for runtime minutes is important because runtime, it started from 1 and ended at 2000, and it was a continuous value, so we couldn't just make it we couldn't encode it. That's why binning was required. So let's bin it before encoding it, and now it's encoded. The same binning will happen for start here because they were like continuous value and it was too big, so we have put it in bins from 1870 to 1990, 1990 to 1930, and these are the bins that we've created. We'll just run them and then encode the start here as well. Same encoding for happening for ordering, characters, category y, tconst genre, and runtime minutes. Everything is just getting encoded by one single function. Now again we're removing the values that were null, and data cleaning is happening again, so we're just removing them, and we'll just see that if it's run or not. So let's just get back and see if our genre ratings is encoded correctly or not. It is. So like you can see all that the data is all in numerical text. The runtime minutes, those were so big, were ranging from 1970 to ranging from 0 to 2000 are all binned, and the data is clean and nice. So that's that. Okay, so now after the label encoding, the time is now to make the correlation matrix. So for that we'll install the core plot and library. We've already installed it, and then we'll download the R color brown library, and now we're just plotting it here, and here the matrix is made, and now we're printing it. And from here we can see that the average rating has a high relation with runtime minutes, as we said in the presentation, and the nconst is has a good relation with average ratings, and likewise. So this is made.
Hi, this is Priyanka Punjabi, and I will be discussing regarding the data mining component. The main focus of a component is to predict the success or failure of a movie, TV series, or episode based on certain features such as genre, runtime minutes, etc. To do so, we had to identify an attribute based on which this prediction could be done. Average rating was one such attribute. Next, we had to identify attributes based on which the ratings of a show is determined. This means that there can be certain actors, directors, genre which could affect the success or failure of a movie. To do so, we performed feature selection as discussed before, which gave us a correlation matrix. This matrix helped us identify that runtime minutes, start year, genre were certain attributes that had correlation with the average rating. The two main techniques used for the classification process is naive Bayes and decision tree classifier. Let's start with naive Bayes. Our first classification technique is the naive Bayes classifier. To perform naive Bayes classification, we first split the entire dataset into training and testing data. We pass this training data in the naive Bayes function, which computes the conditional posterior probability of a categorical class variable given independent predictor variable, in our case average rating, using Bayes rule. Once the model is trained, we use this model as a basis to predict the outcome of the test data. This predicted outcome is then tested with the actual outcome to verify the accuracy of the model. We used the inbuilt function in R to perform naive Bayes classification. It included two components: an a priori, which was a class distribution of dependent variables, and tables, which was a list of tables, one for each predictor variable. The result is a confusion matrix depicting the number of correct and incorrect prediction outcomes against the actual outcomes. Based on the number of correct predictions, the accuracy of a model is calculated. As we can see, our model gives an accuracy of 93.72%, which means it gives a correct prediction of an approximate 93% of the times. Since all attributes are independent, it is much faster to compute a naive Bayes classifier. Now, let's look at a demo. As you can see, the naive Bayes classifier is a part of the library E1071. So we just include that library. This is a printing process wherein we bin the average rating into classes so that it is easy for us to perform classification. We sample our entire dataset as a training and test data. Once it's done, we run the naive Bayes function, which is there on the training data. Once the model has been trained, we use that model against the test data to perform a prediction. Once the prediction is done, we create a confusion matrix. As you can see, here is a confusion matrix. Now, let's plot this. That's naive Bayes classifier.
Hi, my name is Neel. I'll be talking about decision tree. Decision tree is the second classifier that we have used, and for decision tree, we have included the packages rpart, rpart.plot, and caret. The first step over here was the average rating which we had in our data set was continuous data, so we have binned it into 10 integer values from 1 to 10. Second thing that we did was we have split our data set, which is of 100,000 rows, into 80-20 ratio, which is 80% for training data and 20% for development for testing data. The third thing that we did was we ran the model for we ran the training algorithm on the training data, and finally we did the prediction part. This was a decision tree that was formed when we ran it previously, and after the prediction was done, we did we checked the accuracy by building the confusion matrix. The accuracy which we got was 54.58%. Now I'll walk through the code and I'll build it once again. I'm including the libraries. This is the binning part. So if I go and see the data frame, average rating has continuous data, so I have binned it into integer values of 1 to 10. Binning is done. Then this is the training data, which I am taking from 1 to 80,000. Then I am taking a sample, taking test data from the sample, which is 80,000 to 100,000. Now I'll do the training part. So you can see that the attributes that I have considered are runtime minutes, number of votes, start year, and category. These are the attributes that we selected during the feature selection process. And finally, the decision tree. So as you see here, it starts from number of votes, and then start year, and then again run number of votes, then runtime minutes. That's how it's building the decision tree on our data. Also, this shows the summary of our decision tree, and then now I have done the prediction part on the test data. If I print it, this is the prediction part, which is like the prediction. This is the bind rating, which it shows like that. So if you see here, bind rating is it says like do not include 6 but include 7. So this is the bind rating of average rating. And now I'll build the confusion matrix. So here I'm getting an accuracy of 57%, which is slightly better than what we got it from the previous run. And we get a sensitivity, specificity, and then positive prediction and negative prediction value. So we see that we get some good values over here, these classes, and then somewhere we get not a number also. But yeah, so this was the confusion matrix for decision tree.